Right. Here's the equation we want to solve. It's a Bernoulli equation, and we're supposed to find both the general solution and solution with this initial condition. So the trick in these Bernoulli equations is I set y equals some power v, let me call it alpha. Then y prime is going to be alpha v alpha minus 1 v prime. Plugging this into the equation, we get alpha v alpha minus 1 v prime minus 3 v to the alpha is 24 e to the 2x y, which is really v to the alpha cubed. Right, so we're now going to make it look like a first order linear. So let's divide through by what's in front of the derivative term, and that gives me v prime minus 3 v to the alpha over alpha v to the alpha minus 1 is 24 e to the 2x v to the 3 alpha, and on the bottom I have an alpha v to the alpha minus 1. V prime then is over here, over here nice things happen. I just have 3 over alpha v. So this part here looks just like what we want for a first order linear equation. Over here I'm going to have, let's see, 24 over alpha e to the 2x, and this is going to be v to the 3 alpha minus alpha plus 1, which is 24 alpha e to the 2x v to the 2 alpha plus 1. Now, if this exponent is 0, this term, this whole term here will just become 1, and I'll be a first order linear equation. So we're going to set then 2 alpha plus 1 equals 0, which says that alpha is minus 1/2. If I put that in the equation here, we get v prime minus 3 over minus 1/2 is 24 over minus 1/2 e to the 2x and times 1, where I'm using v to the 0 is 1, so I can ignore that. Now this, and I've left out a v here. Dividing by minus 1/2 is the same as multiplying by 2. So this is v prime plus 6v equals, now that's minus 48 e to the 2x. So this is now first order linear. So I'm going to get the integrating factor, and that is just e, and I'm just going to integrate the 6 this time, 6 dx. So this is e to the 6x. So multiplying this by e to the 6x, we get e to the 6x v prime plus 6e to the 6x v, and that is minus minus 48 e to the 2x plus 6x, multiplying that through. This side then becomes e to the 6x v prime, and this side becomes minus 48 e to the 8x. Okay, since this is a derivative, I can get rid of that, get rid of the derivative by just integrating e to the 6x v is minus 48 integral e to the 8x dx. That's minus 48, and that's going to be e to the 8x over 8 plus a constant of integration. And let's see, 8 goes into 48 6 times, so that's minus 6 e to the 8x plus c. So now multiply by e to the minus 6x to isolate the v. So v is e to the minus 6x minus 6 e to the 8x plus c. Distributing gives us v is minus 6 e to the 2x plus c times e to the minus 6x. And so this is going to be the general solution. And we, I take that back, we're not quite there yet. This is what v is, but remember y is v to the alpha, which in our case is v to the minus 1/2. So this gives us, the minus 1/2 is going to say that this is 1 over the square root of minus 6e to the 2x plus c e to the minus 6. Let me write that a little more readably. So this is 1 and then the square root of minus 6 e to the 2x plus c e to the minus 6x. Okay, so this is our general solution, and we were looking for a particular solution. Let's go back and see what we wanted. Y of 0 equals 1. So y of 0, plugging that in here, is 1 over the square root of minus 6 e to the 0, which is just times 1, plus c e, and that's going to be another e to the 0, which is just 1. And we want that to be 1. So this is 1 over the square root of minus 6 plus c equals 1. I can take the reciprocal and get the square root of minus 6 plus c is 1 over 1 equals 1. Squaring minus 6 plus c is 1 squared is 1. So c is 1 plus 6 equals 7. So the particular solution for the initial value problem is y of x is 1 over the square root. C is 7. Let's put that positive term first. 7e to the minus 6x minus 6e to the 2x. And we've got it. And let me just say, once you have an equation like this, just remembering to do this substitution here, then all you have to do is remember how to just realize that you want to make this coefficient 0. The only thing that's going to make it harder is the algebra, the integrals involved. All right.